Nearly 4 kilometers beneath the surface, the ocean enters a state of permanent darkness. Here, pressure is extreme, temperatures hover near freezing, and any technical failure becomes critical. For decades, the Titanic was believed to be unreachable, protected by the very environment that swallowed it. But technology pushed past that boundary, allowing human eyes to descend where none had before, revealing not just a shipwreck, but a sight slowly fading away. What truly waits at the bottom of the Atlantic is not myth, but silent evidence of time, engineering, and tragedy. Before we continue, like the video, subscribe to the channel, and tell us which city you're watching from. The Titanic sank in the early hours of April 15, 1912, during her maiden voyage from Southampton to New York. More than 2,000 people were on board, and the impact of the disaster was immediate, reaching newspapers, governments, and shipping companies around the world. The tragedy exposed critical failures in safety protocols, from the shortage of lifeboats to an overconfidence in naval technology. Over time, the ship became more than a historical accident. It became a turning point in the relationship between engineering, risk, and collective memory. Today, the site where Titanic rests is treated not just as a wreck, but as a submerged historical sanctuary. After the sinking, the Titanic's exact location remained unknown for more than 7 decades, despite searches and eyewitness accounts. Only in 1985 did a team led by Robert Ballard and Jean-Louis Michel confirm the site, using systematic surveys and towed cameras. From that moment on, Titanic was treated as an archaeological site, where value lies in context, not objects. That's why modern expeditions follow strict navigation and documentation rules, avoiding unnecessary contact with fragile structures. The goal is not to collect souvenirs, but to document a place where science, history, and memory converge. Even with modern technology, locating a wreck of this scale requires patience. The debris field stretches for miles, with many fragments partially buried in sediment. Teams rely on sonar, altimeters, and low-light cameras to map the area before approaching any major structure. Preservation is uneven. Some sections hold their shape, while others collapse under corrosion and internal failure. That's why each expedition prioritizes precise recording, video, photogrammetry, and measurements, tracking change year after year. This care is what sustains the idea of a historical sanctuary, a place where science observes but interferes as little as possible. The Titanic rests in the North Atlantic, roughly 370 miles off the coast of Canada, on an isolated abyssal plain. At nearly 12,500 feet deep, pressure exceeds 380 times that of the surface, enough to compromise any poorly designed structure. Temperatures remain near freezing year-round, and total darkness makes navigation entirely dependent on instruments and artificial light. At this depth, there is no margin for error. Constant pressure strains, cables, seals, and connections, demanding equipment built to endure extreme loads for hours at a time. Any electrical failure, loss of propulsion, or contact with the seabed can jeopardize the entire mission. That's why every movement is slow, deliberate, and continuously monitored from the surface. Here, the environment sets absolute limits. Relentless pressure, constant cold, and complete darkness make every operation dependent on extreme precision. The Titanic does not rest on a calm seabed, but on an unstable plane shaped by slow currents, sediment shifts, and corrosion. Every approach carries real risks, both to the equipment and to the historical site itself. Reaching the Titanic requires a complex technological chain. It begins at the surface, with a support vessel capable of holding position for hours at a time. From there, submersibles and ROVs descend slowly, tethered by cables that deliver power, data, and live video. The mission depends entirely on sensors, because the human body could never survive this environment directly. Seeing at nearly 4,000 meters means replacing human senses entirely. Low-light cameras, scanning sonar, and altimeters guide the vehicle through a world without natural visual references. Even then, visibility remains limited. Every image captured is the result of constant adjustments, balancing light, distance, and suspended particles. Documenting the Titanic today goes far beyond observation. Teams use photogrammetry to build precise three-dimensional models, combining thousands of images taken from multiple angles. These records allow scientists to measure deformation, track structural collapse, and compare changes over time. It's a way to preserve information, even as the physical material continues to decay. Despite all this technology, human presence here remains indirect and limited. Every image of the Titanic depends on machines operating at the edge of possibility, controlled from miles above. Working in this environment demands precision, patience, and respect for a place that allows no mistakes. If you want to keep following these expeditions and see how science studies the past beneath the sea, subscribe to continue this journey. The wreck doesn't appear all at once. First, surfaces break the darkness, vertical lines that don't belong to the natural environment. As the vehicle moves closer, scale begins to emerge. Steel plates, rivets, and structural curves still recognizable. In that moment, Titanic stops being a point on a map and fills the frame. The bow of the Titanic remains surprisingly intact compared to the rest of the ship. Its hydrodynamic shape and relatively controlled impact with the seabed helped preserve large sections of the forward structure. Even so, corrosion advances steadily. Railings, hatches, and edges reveal decades of quiet deterioration. Unlike the bow, the stern suffered a violent collapse during the final descent. By the time it struck the bottom, the structure was already compromised. The result is twisted steel, crushed decks, and exposed internal systems. Here, the wreck is defined not by form, but by disorder, revealing the force of the breakup. The so-called secrets of the Titanic aren't hidden behind sealed doors. They're scattered across the debris field. Everyday objects displaced during the breakup help reconstruct interrupted routines and final movements. Each item on the seafloor acts as archaeological data, defined by position, wear, and its relationship to the surroundings. The breakup exposed spaces never meant to be seen from the outside. Hallways, staircases, and internal compartments were torn open as the structure failed during descent and impact. These exposed areas reveal how the ship deformed, indicating force directions, progressive collapse, and the violence of the rupture. Many recovered objects hold little value on their own, but immense value in where they rest. Dishes, utensils, and personal fragments were displaced during breakup and descent, forming patterns that suggest internal roots and collapse zones. These distributions offer indirect clues to how the ship fragmented in its final minutes. Some of the clearest evidence of the final hours lies in the metal itself. Bent plates, torn rivets, and irregular fractures mark points of extreme stress. When compared with earlier records, researchers observe new collapses and shifts, proof that the site continues to change, even in total silence. Among the wreckage, certain objects stand out for their unusual preservation. Thick glass bottles, furniture components, and ship hardware endured better than fabric or light wood. These materials help identify functional areas of the ship and show how different substances reacted to pressure, cold water, and impact. When personal items appear near specific structural sections, they help trace routes through the ship. The distribution of debris, combined with deformed steel and exposed compartments, reveals how breakup and descent reorganized the interior in minutes. What we see is not a frozen moment, but a physical record of collapse. The Titanic is not static. Much of the steel is being consumed by microorganisms that form structures known as rusticles. These colonies accelerate corrosion, slowly turning thick plates into fragile material. The process is gradual but relentless, and it has already transformed areas documented during early expeditions. Since the first expeditions, entire sections of the Titanic have vanished. Decks have collapsed, masts have fallen, and once visible details are now gone. Comparisons across decades show degradation is uneven. Some areas resist, while others fail rapidly. Researchers estimate that recognizable sections of the Titanic may be lost in the coming decades as corrosion weakens beams and joints. Small collapses accumulate year after year, erasing details critical for study. That's why current documentation is a race against time, preserving information before the structure becomes unrecognizable. Human presence at the Titanic raises an ongoing debate: document for science or preserve without interference. Some argue that recovering artifacts protects information before it's lost. Others believe it alters a site considered a maritime grave. As a result, many expeditions prioritize detailed recording and minimal contact, treating every approach as an ethical decision. The ethical debate comes down to a simple question: is this site a scientific archive or a memorial? Removing objects can preserve data, but it also removes context and alters a place many view as sacred. That's why scanning, photogrammetry, and continuous documentation are increasingly favored over physical intervention. On the ocean floor, silence isn't absence. It's the result of distance, pressure, and time. Here, the Titanic speaks not through words, but through corroded steel, displaced objects, and empty spaces. Every detail connects engineering, human tragedy, and modern science, showing how minutes in 1912 still echo more than a century later. Descending to the Titanic today is more than observing a shipwreck. It's a confrontation with how time reshapes technology, memory, and history. What remains on the seafloor is changing, and what we learn now may not be available tomorrow. To document, understand, and respect this place is one way to keep a story alive that still matters.